Yes, today we want to continue with the roots, that is alpha and beta, of a quadratic equation. And by so doing, we want to find another way or a similar way of deriving the sum of roots and the product of roots. As we did the last time, we quoted and then we found the sum and then we found the product. Now I want to use the roots also to derive it nicely. So right away, let us go to the quadratic equation. So the general quadratic equation is giving us, so this is a general quadratic equation. And from that, we can get the value of x to be equal to negative b plus or minus So this is the value of x, and that is in two folds. So we have negative b plus square root b squared minus 4ac, or negative b minus square root b squared minus 4ac over all over 2a. So with this, we can say that the roots alpha will be equal to then the beta can also be written similarly, and then we take note of the sign. All right. So we also have good. So these are the roots. So we have alpha given us negative b plus square root of b squared minus 4ac, and then that is over 2a, and then beta giving us negative b minus square root of b squared minus 4ac over 2a. So with this established, we now want to find the sum of roots. So straight away, let us find the sum of roots. So sum of roots. So that will be alpha plus beta. So we do this way. Good. So we want to move on. Now, because we have their LCMs as 2a and 2a, we can straight away move on and do the simplification. Right, so let's look at it. We have our 2 as common. We have negative b plus negative b, so that will give us negative 2b. Now, when we come here, we have plus square root, they have minus square root, so we will cancel, and that will be all. So that will be plus 0. So basically, say that everything here reduces to the value that we are actually talking about. So we can say that finally, we will get negative b on A. All right. So we shall get negative b on A. Then concluding that the sum of roots, you can now conclude that the sum of roots will be minus b on A. So this is the sum of roots. Right. Now that we've been able to compute the sum of roots, getting the general value, want to move on and then compute the product of roots. So let's look at the product of roots. So we'll look at the product of roots. So say that alpha, beta. Okay. So right away, let us see how we'll do that. So this is alpha. We're now moving on to beta. Right. Now, we have 2a here, we have 2a there. So at the denominator, we shall get 4a squared. 2 times 2 is 4, a times a is a squared. Now, negative b plus square root b squared minus 4ac, the negative b minus square root b squared minus 4ac. Now, I've seen that this is difference of two squares straight away. So negative b times negative b will give us b squared. And then the two square roots plus a minus, so the minus will triumph, and then we shall get b squared minus 4ac. So now we still need to simplify the numerator and see how things will go. All right, so we want to continue with the simplification. Right, so we have b squared minus b squared cancel. Then we have negative times negative 4ac. So we shall get 4ac on 4a squared. Now, when we simplify, the 4 will divide 4a, will divide a, so we get c on a. Now, with this established, we now come to the conclusion that alpha, beta, that's the product of roots, will give us a on c. Right, so right. So alpha beta will be C on A. Fantastic. So let us try and see how we can get an example. So we want to look at an example. So example. So 1. Okay, so find the sum of roots. If 3x squared minus 5x plus 7 is equal to 0, and the product of roots. So we are going to find the sum of roots and the product of roots. So we say that solution. So we say right away solution. Right, so the solution will be, we have 3x squared. Let's look at the equation under discussion. I want to look at the equation under discussion, and then from there we'll see how so the equation is 3x squared. The equation is 3x squared. All right, so first, let's see how we can actually answer that. So we have 3x squared minus 5x plus 7 equals 0. Plus 7 equals 0. Now, we want to divide through by 3 so that the coefficient of x squared will be 1. Then we shall get 5x. Then, because we divide through, we have to divide through by the coefficient of x squared. So when we do that, then we shall get this. Now, from here, we can now find the sum of roots. So, our sum of roots. So, let's just find our sum of roots. So, sum of roots will be alpha, beta. Sum of roots, that is alpha, beta. So our alpha, beta, then we bring our equal sign. So alpha, beta will be, now let us look at it carefully. Remember, it's always negative, so it will be negative, negative, and that will give us negative into negative 5 on 3, so we shall get 5 on 3. Okay, so that does it for this type, and we are done for that. Okay, so now we move on to the product of roots. So we want to look at the product of roots. So let's look at the product of roots. Product of roots, and that will be alpha, beta, and straight away we shall look at, so let's look at the expression. So that will be our 7 on 3. So 7 on 3. Good. So that does it for this one. So anytime we have the expressions, we can straight away do that. It's always negative b over a. Whatever b that we have, we negate it, and then over our a. So our sum of roots is alpha plus beta. That gives us negative 5 on 3, and that is 5 on 3. And then we have our product of roots, and that is alpha beta 3 on 7. That is 7 on 3. Fantastic. Okay, so I'm writing the question and then you try that. So try following. So you are trying this. So try if 2x squared plus 6x plus 3 equals 0, find the sum of roots and the product of roots. Okay, so try this one. Let's see, if 2x squared plus 6x plus 3 equals 0, find the sum of roots. And then also, find the value of A, 1 on alpha, B, and then C. All right. So we want to see how we can also find the values of this one. Okay. So try them. And when you get the answer, we'll look at them at the next time we meet. Thank you so very much for your time and continue to practice what we have done this evening. Goodbye for now. Bye-bye.